Let's be real for a second. The hard drive, it isn't exactly the most exciting piece of tech, right? It's kind of the beige box of the computer world. But what if I told you that inside that boring box, a secret war is being fought? I'm talking about an absolutely epic, high-stakes battle for the very future of data itself. Okay, so let's set the stage here. Every single second, we're generating this unimaginable flood of data. We're talking cloud computing, the Internet of Things, huge analytics projects, the whole shebang. Our digital universe is just expanding way faster than we can build space for it. And that brings up a really critical question. Where in the world are we going to put it all? Well, the answer, believe it or not, still lies with our humble friend, the hard drive. But listen, this is not your grandfather's hard drive. Oh no. To win this war for space, engineers have had to transform it into a total marvel of precision engineering, one that's fighting on two separate and equally incredible fronts. So that first front, it's a war of pure mechanics. We're talking about a microscopic, high-speed ballet of moving parts, where even a single tiny misstep means absolute data disaster. And right at the heart of this dance is the actuator assembly. Just think of it like the arm of a record player, okay? But instead of a needle, it's got a reed/write head. And instead of a vinyl groove, it has to find a data track that is literally thousands of times thinner than a human hair, all while the disk underneath it is spinning at thousands and thousands of RPM. Insane. So the early drives, they used these things called stepper motors. And they were clunky and not very precise. They also got super hot, which was a huge problem because that heat could cause the disk platters to expand and risk a catastrophic head crash. Not good. The first big leap forward was the voice coil motor. This thing uses a really clever feedback loop to constantly monitor its own position and self-correct on the fly. It's basically the difference between walking around in the dark and having a high-tech GPS guiding your every single step. But as you can imagine, data tracks just kept getting smaller and smaller, and soon, one motor just wasn't enough. Engineers had to take that precision to a whole new level. And this analogy from a Western Digital white paper just perfectly captures the solution they came up with. And this right here brilliantly shows that solution. It's called the multi-stage actuator. You've got the main voice coil motor making the big, sweeping movement. That's what gets you onto the highway, right? But then you have these tiny piezoelectric joints, and these things expand and contract with just a zap of electricity, making these microscopic, nanometer-scale adjustments to keep the head perfectly, and I mean perfectly, centered in that impossibly thin data lane. And the innovation, it doesn't stop there. Seagate is actually using two independent actuators in one drive, which literally doubles its IOPS. That's its input/output operations per second. So basically how fast it can read and write all those little bits of data. And meanwhile, Western Digital is using this cool dual pivot design to squeeze the spinning plotters even closer together, packing more and more storage into the exact same physical space. But, mastering mechanics was only half the battle. Let's move on to the second front, a front where engineers weren't just fighting things like friction and vibration. No, they were fighting the fundamental laws of physics themselves. Okay, so this is the core physics problem. It's known as the magnetic recording trilemma. See, to store data reliably for years and years, you need a material that is magnetically stable. But here's the catch. A stable material is, by its very definition, hard to change or write to. And if you make it easier to write to, well, it becomes less stable. These three needs are just in this constant tug of war, and traditional tech had completely hit a wall. So, engineers realized they couldn't win this tug of war just by changing the materials. They had to find a way to kind of cheat physics. The solution was to add a temporary burst of energy, right at the exact nanosecond a bit of data is being written. What this does is make the material briefly easy to write to before it instantly snaps back to a stable state. It's genius. Now, this whole energy-assisted approach has led to three competing technologies. First up is HAM. That's heat-assisted magnetic recording. It uses a tiny laser to heat a spot on the disk to over 400 degrees Celsius, but just for a moment, making it easy to write. Then you've got MOM, which uses microwaves instead of heat to get a similar effect. And finally, there's eARMR, which takes a more conservative approach, just using a small jolt of electricity. And as you can see, both HAM and eARMR are already out there shipping in massive drives, while MOMR is still in the R&D stage. So while all three are really impressive, one technology is currently pulling way ahead in this race to build the future of storage. Let's take a closer look at the HAM revolution. Check this out.
The market is betting big on HAMR, with a projected compound annual growth rate of over 34%. That's huge.
And what does that mean in dollars? Well, it translates into a market that's forecasted to be worth over $214 million by 2031. But here it is. This is the number that really matters to us. 50 terabytes. 50. That is the capacity that manufacturers are targeting for a single hard drive in the very near future, using this exact technology. And this brings us right back to our original problem, doesn't it? This explosive growth, it isn't just for fun. It's being driven by the relentless, absolutely insatiable demand from the data centers and the cloud providers who are just desperately trying to find a home for all the photos and videos and information that make up our entire digital lives. But this revolution isn't without its challenges. There's a price for all this progress. And believe me, there are still some pretty significant hurdles on the horizon. First off, this new tech is expensive. I mean, we're talking microscopic lasers and exotic materials. That stuff drives up costs. Second, there are still some question marks about long-term reliability. I mean, can a tiny little laser assembly fire billions and billions of times without failing? Good question. And finally, let's not forget, the hard drive is in a constant battle for market share against its faster, more rugged cousin, the solid-state drive, or SSD. So, the next time you look at a hard drive, don't just see a boring box. See a battlefield. See a device that is locked in a high-stakes race, fighting a desperate war on two fronts, a mechanical war of precision ballet and a physics war against the very nature of magnetism itself. It really is a battle for the future of all of our data. And as hard drives keep getting smarter and hotter and way more complex, it leaves us with one final thought-provoking question. As we look to the future, will the world of storage be defined by this ongoing battle, or by an eventual partnership between these two incredible technologies?